let's see all of this. So, if you need to look at the board over there with some hints on naming lines, planes, rays, and whatnot again, after the weekend, do what you gotta do. The naming, I think, is harder than the first one. Okay, use the diagram to identify the following. A line. Well, you got two lines in the picture. So you've got this one here, and you've got this guy where the planes are intersecting. If you're going to do this guy, probably the easiest, I would do line P. Or just, you only need one way, but I can't help myself. You can pick any 2 points on the line and put the line symbol above it. So I could do line AC, line BC, line CA, all day long here. You only need one. I'm just getting carried away. Any questions on how to name a line? Okay, let's take a look at 5. A plane. Well, you have 2 planes. If I'm going to do this one, probably the easiest thing, I would call it plane Y. I just use the Y. Or if I wanted to name this one, I don't know how well it's shaded on your notes. If you want to do the shaded one, I would probably just call it plane Z. Bless you. Now, let's say, just to review, you got fancy on this guy, this white one. Let's say this wasn't on here.
BCF.
So you could call it BCF, plane BCF. The key is you have to pick 3 points. Write the word plane. We have to pick 3 points, and they all can't be on the same line. So you couldn't do ABC. You got to include F in it somehow. So you could have FBC, FAB, whatever. Okay. Array. Well, there's lots of rays here in the picture. I'm going to say ray BA. Ray symbol. You could have ray BC. Would be another one. You only need one though. All right, 3 collinear points. That's easy. What are your 3 collinear points?
ABC.
ABC. And make sure this is nitpicky, capital letters. And you can have those in any order. Segment. AB works with your segment symbol. Give me another segment in there. BC. Give me another segment in there. AC. Well, okay, we got it. We're getting carried away. Can't help myself. Opposite rays. Well, let's use my green one I have up here marked. So I did ray BA. So the opposite one would be ray BC. I like it. Okay, and then let's do the bottom one, which is kind of on the screen there, but that's okay. Identify the intersection of plane Y and plane Z.
Line Q.
So where they meet, which is a line, line Q. Okay, let me ask you a question. How would have you done if this was not up here? Did you need it or no? Okay, some yes and no. And again, the naming we'll continue to practice. I got some more stuff for you for the next couple days before we get to your quiz on Thursday. Are we ready for more vocabulary? Maybe, maybe not. Okay, here's what we've got for vocabulary today. We're going to talk about a midpoint and a segment bisector. Now, there's nothing for you to fill in on your note packet. It's all on there for you. Midpoint of a segment divides a segment into 2 congruent segments. Now, reminders. These little red tick marks mean congruent. So whenever the left side equals the right side, they're congruent to each other. The point in the middle, we call it the midpoint. It's in the middle of the segment. Seems common sense. I like it. Segment bisector. A point, a ray, a line, a segment, or a plane. Everything. It intersects the segment at its midpoint. So again, the key is 2 congruent sides. This time, ooh, fancy, it's a line that's cutting it in half. And the last one, it was just a point, the midpoint. Do they basically do the same thing? Yes. It's just a matter of if you just have the midpoint or if they get fancy, and here they used a line. What we care about is we're going to have the left side being equal to the right side. That's where we're going to start doing some math. Okay, the skateboard didn't copy very well on your notes. It's very gray, but it's supposed to be a skateboard that looks like that. In the skateboard design, XT is 39.9. I'm going to label it on the picture here. XT Hopefully you can see that okay. Identify the segment bisector and then find XY. They're so tiny. I don't know how well they copied. Can you see the little red tick marks? Did those show up on your picture? Can you kind of see those? You might need to bold them in, but they're on there, okay? So clearly I'm going to copy the 39.9 here. So first question it asks you, identify the segment bisector of XY. Well, what's cutting XY into half, into two? This right here. Well, what is this? Segment, line, ray, two endpoints. Segment. So I'm going to call it segment VW or segment WV, however you want to name it. Now it also asks you XY. So what is the total from X all the way to Y? How are we going to figure it out? We're going to add them together. You're using segment addition postulate. Just the gift that keeps on giving. What is that? What's 39.9 plus 39.9? And I'm going to throw a label on, we're in centimeters. Got it. Now, do I really need you to show me work for the 39.9 plus 30? No, you could have just gave the final answer, it's fine. You can add that up in your calculator. All right, did this show up? How well can you see these? Yeah, these marks showed up. Your red tick marks, you can see those, I hope, on that one a little bit better. The last one didn't copy the best. All right, let's do the first thing. Identify the segment bisector of segment WV. What's cutting that in half? Now, when you look at this, what type of picture does that look like that I circled? It looks like a ray. It looks like a ray to me. Here's my question for you. How are we going to name it? Because we have the end point. Do you have the other point?
No.
Okay. So it does look like a ray, but they're not helping us out with the naming. So our only other really choice we have, M is also just a what? Point. So the only choice I have, because they didn't give me the other letter to do the ray, is I only have point M, which I like naming points because all I have to do is write M. Like it. Identify the segment bisector. Okay, we did it. So here's the deal. We probably should solve for X on this. Here's the deal. So yes, I was going to say yesterday, Friday, we were adding the left and the right to the whole thing. I think this is even easier. They're congruent. They're equal. This time I just set the left side equal to the right side. So it's a little less work than Friday. Okay, I'm going to get the x's on one side, just like back in your Algebra 1 days. Remember, it doesn't matter if you subtract the 4x or the 3x. I always do the smaller amount. 4x minus 3x. And I'm guessing you can finish that in your head. X is what? 4. Now, let's make sure we read the directions and answer the problem. It wants the length of VM. Okay, all right, so I'm still working. I still got stuff to do. Well, if you put 4 in here for x, do a little mental math for me. What's 4 times 4 minus 1? 15. Now, let's work smarter, not harder. I'm not even going to overthink it. What's the right side? No work. 15. So what is the length of V all the way to W? 30. 15 plus 15. We got it. Real numbers for once. Gotta like it. Any questions I can answer for you in example. This is like as crazy as it gets, people. All right, identify the segment bisector of PQ. And I think, yep, these look like they copied okay. You can see the tick marks. So clearly this is what's cutting it in half. Now, let's name it. Let's describe it. Is this a point, line, ray, or a segment? Line. And I can name this line. I'm going to name it line L. Okay, next. Find the value of x. Okay, nice. We've got our congruent marks. So this time our left side equals the right side. All right, you guys are up. Do the algebra. Figure out what x is for me. might get a not nice answer. I was trying to think, how can I give you a hint and not give it away? You might need your calculator for this one. And you can round it to the 10th if you want. I'm really giving it away. All right, what did you get for x? 2.6, you get a decimal. This one comes out kind of yuck because you're down to 5x or 5x minus 7. Well, let's just do the answer. You guys had it. I'm not going to bore you with the work. And then, of course, yours also wants you to find PQ. So this is why I said just round that to the 10th, and you're probably going to need your calculator. So in your calculator, what's 5 times 2.6 minus 7? And then what would be the length of the whole thing? 12. Yeah. So let's be honest, in geometry, I'm not going to lie to you, I would say 93% of the time your answers are nice whole numbers. Once in a while, we like to get crazy and throw a fraction or a decimal. Don't let us scare you. All right, identify the segment bisector, and I think the tick mark showed up nice on this one, yep. And then find the value of x. So clearly this is cutting it in half. What are you calling that? What is that?
Ray.
Ray what?
Ray and then.
Perfect. Quick review question for you. Is that the same as Ray NM? Like, could I switch it? Are these the same?
No.
No. So don't get crazy on the rays. Okay, more of the same, of course. We're going to, left side equals the right side. We're going to set them equal. Ooh, this is a good one. X squared. How many answers are we going to get?
2.
2 this time. Now here's a throwback to Algebra 1. To solve this x squared, aka quadratic equation, we should get all the terms on the same side and set it equal to 0. Let's start with that. So I'm going to subtract 7x. We're going to be super conscientious how we order these terms. The squared term goes first, then your linear term, just the x term, and our term with no variable, the constant term. And now we're going to use one of our favorite F words in math. And we're going to factor this to get our solutions. You were scared, I know. What two numbers multiply to 10?
-5, -2.
I didn't even get the question out. Multiply to 10 and add to -7. He's got it. -5, -2. What are your two answers for x? 5 and 2. See, that's why we keep doing all that warm-up, review, factoring. Now, that also asks you, of course, to find PQ. Question: how many answers are we going to have for PQ? 2. We had 2 answers for x. You're going to get 2 answers for PQ. Not that that's a bad thing. It just is what it is. I'm going to set it up here. So first, let's use 5. I'm going to start with the 5. Well, if you put 5 in here, what's 5 squared plus 10? 25, 10, 35. Of course, this side's 35. What's the whole length then? 70. 35 plus 35. Now, if I put 2 in for x, what's 2 squared plus 10? 14. 14. Your other choice for the whole length would be what? 14 plus 14, 28. So if you get 2 answers for x, you're going to have 2 answers for PQ. That is as crazy as this gets today. Questions I can answer on the factoring. So don't let it scare you when you have a factoring one in your homework. Okay, line Q bisects segment AD at y. Find AY. If AY is 2x plus 5, AD is 12x plus 2. Draw a picture. Oh good, my artistic skills. And solve. Okay, line Q bisects segment AB. Well, I'm going to start with segment AB. It's not too bad. Line Q is bisecting it at y. So I'm going to put y in the middle. And I'm going to draw a line through it. I'm going to label it Q. And because it says it bisects, I know the left is congruent to the right. So I'm going to put my tick marks on each side. It's not too bad of a drawing, I'll take it. So AY is 2x plus 5. Got it. AB, oh, different, don't get crazy. A to B is 12x plus 2. A little different. Draw a picture and solve. Okay, all right. So this, I love this problem, is a good little combination here, get ready for it, of all of our segment addition postulate skills and whatnot too. I cannot just set these equal to each other, because that's the left side, this is the whole thing. Let me ask you this question. If the left is 2x plus 5, you can identify the right side. What's the right side? If this is 2x plus 5 and they're equal, what's the right?
2x plus 5.
Yeah. They're the same. So here we go. Throw back to segment addition postulate. The left plus the right, which they're the same. That's going to be easy to add up. Or double, we could have the whole thing. Okay, let's solve. A little algebra. Combine our like terms. 2x, 2x. 5 plus 5. And carry on. Let's get our x's on the same side. I always subtract the smaller amount, so I'm going to deduct the 4x off. I think this is going to turn out pretty nice for us. 8x plus 2. We'll let you finish and solve it. X equals 1. We're the smallest number, right? Okay, let's make sure we've answered everything before I circle anything. Well, yeah, find a y. I need a all the way to y here. So if we put a 1 in here, a little mental math, what's 2 times 1 plus 5? 7. So ay is 7. All right, let's test our skills. For fun, what's YB? 7. What's AB? 14, the whole thing. Just making sure we can answer, different stuff, variety. Oh good, I might draw a picture again for you. You know we love my drawings in here. Segment WE bisects segment DO at H. So just so the pictures always kind of look consistent, I always do the bisector kind of through the middle. So I'm going to put the DO, segment DO first. Oh. And then WE bisects at H. So I'm going to throw H in the middle. Kind of looks like the middle. And I'm going to draw my segment WE through it. I'm going to put my congruent marks on, and there we go. Hardest part for me is drawing the picture because of my bad drawing skills. Okay, find DO. If DO is 3n squared plus 15 and HD is 7n. So similar setup to the last one. So HD is 7n. Got it. Now, careful here. D all the way to O is the 3n squared plus 15, the whole thing. So kind of like the last one, we're going to use segment addition postulate, but we have to know if the left is 7n, what are you writing down for the right? What's the right side? 7n. They're the same. Perfect. So here we go. The left side plus the right side, which you probably could add those up in your head. I'm well aware of it, but I'm going to jot it down. The left plus the right. I know you know it's 14n. I'm going to write 14n in the middle. Equals the whole thing, 3n squared plus 15. So there's the geometry setup. Now we're into the algebra part of it. I know some of you probably skip this and just put 14n. That's fine. Question for you. How many answers are we going to get for n? 2. So kind of just like that previous one we did a couple back, I'm going to set it equal to 0. And we're going to do our favorite F word in math, factor. Now, this time there's only one term on the left, so a little less work. I'm going to make this guy the 0. I'm going to be conscientious of how I order this, meaning I want that n squared term to be first, then the linear term, 14n, and your constant term, just the number with no variable. Now, I cannot just factor it. This is kind of that yuck factoring. We can't just do it like, hey, what multiplies to 15 and adds to negative 14 because of this guy. The 3 is ruining our life. Our lead coefficient's not 1. So I'm going to do that long factoring method where I'm going to multiply the outside two numbers. You might need your calculator for that. What's 3 times 15? 45. What multiplies to 45, this is the hard part, and adds to negative 14, negative 9, negative 5. That's the hard part to me. Now, key step. You're going to divide each of those by what? 3. Now, this comes out nice. We can do that in our head. Negative 9 over 3, negative 3. So there's one of our factors, n minus 3. How do you write this in factor form?
X minus 3, 3x minus 5.
I'm going to go n, 3n minus 5. I know, I got to be picky. I got to be difficult. Okay, carrying on. What are your two answers for n?
5, 3.
Yeah, nice one, 3. We'd have to add 5 and divide off the 3. Whew. Now, I'm almost out of room. So it also asks you, find DO. So we need the length of the segment. You have 2 answers for n, so how many final answers are you going to have for DO? 2. Okay, I'm going to sneak it on here, because I am running out of room. Let's start with the easy one. If you put 3 in here, what's 7 times 3? 21. So you have 21 and 21. So a total of what? 42. That's the easy one. You might need your calculator for this. What's 7 times 5 thirds? We don't need a calculator. 7 times 5. So we have 35 thirds. Love it. And this would be 35 thirds. What's 35 thirds plus 35 thirds? 70 thirds. 70 over 30. We don't need a calculator. We're too good. I love it. We got to factor and we have to do some fraction work. Now, if you have to do the fraction work in your calculator, so be it, but we should be able to do that by hand. That was a great problem. Any questions I can answer for you on that? I don't think you're as excited about it as I am. Okay, let's get to the easiest part of the lesson, my friends, the midpoint formula. So, coordinates of the midpoint of the segment are the averages. I hate to memorize formulas. I just say midpoint's in the middle, so I'm going to do the average. Just like if I want to know the average class score, I total them up, divide by how many scores there are. Same thing. You're going to add your x coordinates, and there's 2 x coordinates, so you divide by 2. You add your y coordinates, there's 2 y coordinates, so you divide by 2. And just to point it out, here's the formula up here on the board. This is our new exciting formula of the day. Well, it looks crazy. I promise this is super easy. All right, endpoints of RS, segment RS, R is at 1, negative 3. You can see in the picture. S is at 4, 2. Find the coordinates of the midpoint. Now, you're going to get good at this. You're probably going to do it with way less work than I'm about to do, which is totally fine, but that's how I'm going to roll for the first one. So we're going to average the x's. Most of you, I'm guessing, if I said average 1 and 4, you could add those up and divide by 2 in your head. I'm going to write it out. So what's 1 plus 4? 5 over 2. 2.5. 2.5, 2.5, 5 over 2, however you want to put it. And then you just repeat the process for the y coordinates, which again, probably most are going to do this in your head. I'm going to write it out. We're going to add negative 3 and 2 together. And there's 2 of them, so I'm going to divide by 2. What's negative 3 plus 2? Negative 1, so I'm going to have negative 1 over 2. Now this one's nice because they give you the picture to look at. They don't always give you the picture. But I'm like, oh yeah, 2.5, negative a half. Oh yeah, 2.5, negative a half. That's right where that middle point is. That's what you're calculating. I just need the coordinates. And again, you're probably just going to do most of this in your heads, which is fine. The midpoint of JK is M at 2, 1. Ooh, different, a little different here. One of the endpoints is at 1, 4. Find the coordinate of the endpoint K. Now I'm not going to get fancy and draw the whole graph grid and all of that, but I am going to draw a picture here because we need a little visual because it's a little different. Okay, midpoint of JK. M is at 2, 1. I'm just labeling everything. And J is at 1, 4. So they want you to figure out the coordinates for K. That's what we're going to solve for, the blue X and Y. Now, a couple different ways you could do this. I'm going to show you the easiest way, the non-book way. Get ready for it. Book way is we'd add the x's, divide by 2, and we'd solve a bunch of equations, do a lot of algebra. We don't have to do that much work, people. We're going to use a little bit of common sense. Okay, let's start with the midpoint, the 2. I'm looking at the x's. From 2 to 1, easy question. From 2 to 1, are you going up or down? Down. You went down how many? 1, right? So, easy enough. To get the endpoint on the other side, I'm not going to go down 1, I'm going to do the opposite. I'm going to go up 1. So if you now go up 1, where is that going to end you up at? 3. So there's the x coordinate. So I had to go down 1 to get to the x, so to go the opposite direction, I went up 1. Okay, let's do the y. Same thing. From 1 to 4. Did you go up or down? Up. From 1 to 4, you went up how many?
3.
So now do the opposite. So if I'm going to go down 3, what's 1 minus 3? Negative 2. So you just have to remember you're starting at the midpoint and comparing. Now just to show you, if you're like, oh gosh, I'm not going to remember that, that's so much, you can set up an equation if you want to get crazy. For instance, I could do x1 plus the x coordinate I don't know, and I know it's supposed to equal the middle. If you go through and solve this equation, you get 3, okay? If you want to do an equation for y, so I'm going to do the y coordinate plus the y on the other side over 2, and I know it's supposed to equal out to a 1. If you go through and solve that, you'll get negative 2. I don't care how you do it, how you get the 3, negative 2. Yeah, I personally just count and go the opposite direction. If you like an equation, I just wanted to show you the equations too. However you want to do it. All right, any questions about that last one? That's the trickiest one. Too easy. So let's grab your homework here. So just for the record, to help the cause. Let's give you that. 1, 4. Larry's got one. Alex, you're not on your phone back there, are you? Thank you. Larry's got one. I see everything. I see everything, Alex. All right, so everybody got one? So these are very similar. Here, let me put the notes back up here. Okay, click it back, guys. Click it back. So like these, where you have to draw the picture. I didn't draw the picture. So it's telling you to draw the picture, of course, solve for x, and show your work. So you have to, I know this is the yuck part, draw a picture for every single one on 1 through 5 first, and then solve for x and answer with the second like this. When you get to the back side, easy. Midpoint formula, that's going to take you like 10 seconds. And then there's some other review stuff on there, some bisector, some naming, some easy stuff. The front will take you the longest. So don't be like, oh my gosh, this is the worst worksheet ever. No, no, no. Get through the front and then it gets easy, I promise, okay? Don't give up on it. Never. Never.